Differentiate the function r of theta equals sine theta raised to the power of cosine theta. When we have the variable theta in both the base as well as the exponent, it becomes tough to differentiate. Let's simplify this equation by taking the logarithm of both sides. By the properties of logarithms, we can bring that power down as a multiplicative factor. This function now looks like something you can deal with using the product rule. We have one factor, cosine theta, multiplied by the other factor, ln of sine theta. Differentiate the equation with respect to theta. Notice that r is dependent on theta, so then we have to differentiate implicitly. Whenever we differentiate something with an r, we have to multiply on a factor of dr d theta. Differentiating the ln r now, ln differentiates to 1 over r, and then multiply on dr d theta. And applying the product rule, differentiating the cosine, we get negative sine theta. I often forget to put the negative, so just keep in mind that cos differentiates to negative sine. And then keeping the other factor the same, ln sine theta. Add, keeping the previous factor the same now, cos theta, and then differentiating that other factor. Ln turns into a 1 over sine theta, then differentiate the stuff inside the ln, sine turns into a positive cos. Assignment and exam questions often want us to express the derivative explicitly. Dr d theta equals something that has only theta. Let's do that. Multiply both sides of the equation by r to get rid of that 1 over r. Another thing to keep in mind is that we're multiplying the entire right side of the equation by r. We're not just multiplying r to a single factor of the entire thing. So this entire right-hand side should be enclosed in these big parentheses. And r is dependent on theta, and we just replace the r with what we were told r is equal to, sine theta raised to the power of cosine theta. If we wanted to, we could simplify this derivative a bit. The first thing I notice is that we have a cos multiplied by a cos. Let's turn that into a cos squared. Another way of simplifying this derivative would be to bring together a cosine, any one of those two cosines, with that 1 over sine to get a cotangent. Any of these ways, the first answer, the second, or the third answer, these are all equivalent and should be considered correct. The tough part is that on a multiple choice question, we might see only one version of this answer, even though there are multiple ways of expressing this derivative. Differentiate the function y of x equals x plus sec x, the whole thing, raised to the power of 4 over x. The variable is in the base as well as in the exponent position. Let's use the properties of logarithms to bring that exponent down. Take the natural logarithm of both sides of the equation. Ln of y equals ln of that entire thing. Bring that 4 over x down as a multiplicative factor. Put that x on its own as a denominator. So far, calculus hasn't happened yet. We're just using the properties of logarithms to rearrange this equation so that it's easier to differentiate. Now we differentiate. Ln of something differentiates to 1 over that, 1 over y, and then because y is dependent on x, we have to differentiate implicitly, multiply on a factor of dy dx. Applying the quotient rule, differentiate the numerator, 4, just put that constant aside, differentiate that logarithm, 1 over x plus sec x. By the chain rule, differentiate the stuff inside the logarithm. 1 plus sec differentiates to sec tan, and then multiply on that denominator x, keeping the denominator unchanged. Subtract. Keeping the numerator unchanged, 4 ln of x plus sec x, and then differentiate the denominator. X differentiates to 1. And by the quotient rule, square that denominator. Though optional, we can factor out the 4 to put on top of x squared. That's the derivative, although assignments and exams often want an explicit answer. Dy dx equals something not. Dy dx multiplied with something with a y in this case. Let's isolate dy dx. Multiply both sides of the equation by y. Write y in terms of x, which was defined above in that given equation. If you like to leave 4 over x as is as a factor, and then use the product rule to differentiate, that works as well.